We can book him again next week.
Okay, cool. Hi. All right, we got a lot of
Welcome,
news now.
everybody.
Hi. We didn't actually talk
Welcome
about
to
the news last time.
Agents for Humans. So another riveting week we got for you here. Joseph, what have you been up to? You want to, for those newbies, you want to give a real quick intro and maybe a little bit of something cool that you worked on this week?
Well, I want to show what I'm doing, and I just want to show our special guest Ryan,
Woo!
who he can present AI IQ. He's the progenitor of the super good eval framework AI
Hello, how's it
IQ.
going?
How's it going, Ryan? Nice to meet you.
Nice to meet you, Doug. Douglas.
You've been doing some
Ryan's
super
actually
cool
up
stuff.
Yeah,
Ryan's
thank you.
actually upstairs, so you should come down. We should hang out here down here too. But the audio
Yeah,
quality will be better.
I'll come over and I'll join you over there. That'll be better.
I can talk a bit about my stuff first. Some innovations that we Trusted Router did, or you want to talk about AI IQ also?
Yeah, go ahead. You go first, and I'll go after you.
Yeah, so generally, like what we'll do is we'll do like a little intro, who we are, something cool we've been working on, and then we can show some little demos, and we've also got some news topics I'm sure that we can get into and just give our opinions, and then try to wrap it up like within by the top of the hour.
Sounds great.
Cool. Joseph,
yeah, it's pretty informal. So I'm gonna share. Don't show these tips again. All right, sharing this window. Yeah, so Trusted Router is the project I've been working on, and we're getting some really interesting results. I showed a little bit before, but here's another one. We created a model called Socrates that is getting higher than Fable and GPT-5.5 and even 5.6. That's not even released yet on the terminal bench hard coding agentic coding benchmark. And so this is like beyond the frontier, and that's because we are looking, basically the fundamental intuition is that no model gets everything right, and the models aren't strictly better than any one. Everyone's saying, oh, this model's better and this model's better the next week, and that means that they have jagged edges in intelligence. Some models are smarter at this, some models are smarter at that, and that works even within a type of problem. And so if you look at this, how do I zoom in? This is the terminal bench hard. Some of them get polyglot Rust problem, and some of them get the Git web server problem, and no one gets all of them. But if we create the union of them by combining models, then we can actually get something that solves everything. And that's why the combination model Socrates is actually solving all of these problems better than any single model, including the big labs. And this is what it looks like. This is what Socrates looks like. It first routes to a really fast cheap worker that's doing things really fast at 1,000 tokens per second. And then if that gets stuck, it has the option to call a tool which says, get advice, basically. I mean, it's literally called get advice. And it says, I'm stuck, give me some advice. And then that goes to a really smart advisor. And that's actually 7 models in parallel. And so this ends up still being fast because we're doing it in parallel. But these 7 models include GPT 5.5, Opus 4.8, and then the other 5 top models. Then that goes to a KLM 2.6 judge that takes all the ideas in there and like collates them and figures out, oh, here's what everyone agrees. Here's like the unique insights. Here's the information. And then the synthesizer takes that, puts it together, and comes out with a final answer that's returned. And the interesting thing about this is I've taken a whole complicated orchestration agent harness and put it into a model, and I call it Socrates. And it's Socrates because it's like a teacher. It's like oh, here's a teacher-student relationship. And so you still can just use it as a normal model everywhere in your favorite coding harness, in Codex, in open code, in whatever, in your production pipeline. And it's actually usually faster for almost everything you do, because again, the first model is just a cheap, fast model. But on top of that, it's actually smarter than any other model that you have because it has an advisor that's actually 7 models. So this is actually 8 models put together. And I'm already designing ways to actually put 10 models together and make it even faster using Cerebrus chips.
So and this is something. The cost, how does it compare to like say like Socrates to Fable? Is like, I guess it differs depending on, it's sort of a flexing cost is because it depends on which ones are used for the problem. Is that right?
It varies, but
Uh-huh.
the fast cheap model calls the advisor less than 10% of the time.
Mm.
So because of that, it ends up being still cheaper than calling Opus 4.8 actually.
Mm-hmm.
And so it ends up being faster, cheaper, smarter.
That's incredible.
By combining all the models. And this is something that big labs can't do because they're focused on, how do you say, it's like a monotheistic religion. They're saying,
Mm-hmm.
oh, there's only one God, there's only one Claude, and there's no other, any other Claude is a false Claude. And actually, if we're moving toward polytheistic, it means we're going to have a ton of models and a ton of providers and a ton of chips. It's not going to be a monopoly of just one model or even one AWS, not one, NVIDIA chip. It's going to be Cerebrus. It's going to be Grok. It's going to be this other chip that just launched today called Etchy. And by doing that, but even any of them are not going to be perfect. So actually the best thing is to use a trusted router and route to the best task at every moment. And that's what we're providing now. And this is kind of the vision. So what if you can create your own combo model? And it's a model that's actually like a container, like a container and a container ship. But inside it can be like a bunch of models stick together, right? In a combination. And there's all kinds of combinations you can do. The idea is you can have like a synthesis model, an advisor model. You can do routing. You can do MapReduce. You can combine these circuits in different ways, and then make a really complicated model inside. But then on the outside, it's just a normal model. You ask it a prompt, and it gives back tokens. And so, what if there's like a marketplace of this where you can go on and hey Ryan,
What?
and what if there's a marketplace where you can, so Ryan and I are talking about making a marketplace where you can like put in your prompts, make a model that's complicated, smarter, faster, cheaper, or all three, and then you sell it, and then you take like, a cut on top of it. Anyways, that's the things we're playing around with.
That's so cool. So, I mean, trusted router, you're tackling a few things concurrently here. You are, first of all, more private than competitors because you're
Yes.
using encryption in multiple places.
Yes.
Secondly,
and that's important for the marketplace because you're trying to keep your technology secret. And by being private, people can trust that it's not getting stolen. Your data's not getting stolen.
And so a lot of places, that are routing is like you send stuff, they can potentially see it, but so that's protected, but you can also offer recommendations for models that also, even the way they deal with it internally, because you're sending it to them where it's out of your control, but at least they often have agreements of how they're using data. So you can kind of like advise on this completely encrypted or private data flow. Two, people are so overloaded, unless you're a real computer scientist looking at all these benchmarks and things like that. They're so overloaded with, I don't know when to send what to where. I don't know what thinking means. I don't know how smart I need this to be. So they're often just maxing out and spending way too much on things they wouldn't even need. And then three is that sort of relates to the cost, is like then you're giving that frontier level intelligence or then some. You're reducing the cost. You're making the decision easier. It's so like a win across the board, which is super cool. And the privacy on top of that, which is just like, yeah, it's just incredible.
Yeah. And Ryan's coming down now, but I wanted to represent AI IQ, which is really cool because I used it to help inform me on what model to use. Because when you have hundreds of models, like on Trusted Router, you can put, and there's literally millions of combinations you can put them together in. And so which one do you decide? Do you decide this cheaper one, but maybe it's less intelligent? So here's that website. And then and another big thing about what I'm doing is that since last week, everyone's talking about open source, right?
Yeah.
Everyone's talking about moving from Claude to an open source model, both in enterprise and among the open source crowd. Everyone I talk to, all of our customers are like, yeah, we need open source. And that's the best way, the easiest way to use that with trusted router. A lot of people in legal and financial services and healthcare want to use trusted router because it's encrypted, and again, you're confident that the data is going to be secure. And yeah, that's what we're pretty excited about.
That's so awesome. Well, so maybe it's like the secret sauce. You don't want to talk about it, but are you helping?
We're all open source. Everything's open source, by the way, on trusted router, so you can have full faith and trust in it.
Oh, that's awesome. So are you using benchmarks to determine where to best send specific requests? Are you using other benchmarks to be like, oh, that's the right request for this model?
That's a good question. We haven't built the router model yet, where you give it a prompt and it figures out which other model or a combo model to send it to. But Ryan wants to build something called like Task IQ, where it figures out what to send it to, and it sends it one or the other.
Socrates, like it's realized, like you showed us that grid or like the check boxes, like something's not good at Rust or whatever. Like, is it determining that from the actual prompt itself? Is it like how is it determining, or is it like it's not getting all of the answers and then like compiling the answers from all of them, is it?
It depends on the model, but the advisor model, the base model decides when to call the advisor, and it's intelligent. I mean, the models are intelligent enough today that they can just know when they don't know something and then ask the advisor. So that's part of actually the whole vision I have about Claude Virtual Machine. So instead of writing code that figures out how to connect everything, the models themselves are going to have the intelligence to decide when to do that. And then when it goes to the advisor, which is a Prometheus model, or a Zeus model, actually, which is a panel of 7 every top model, that is calling all of them in parallel for each agentic step. It's calling all of them, analyzing all the answers, and then going.
That's incredible. So I'm just putting a little comment on our message board with those links and a little bit of context. So is Ryan is he in there?
Yes, he's here now, finally.
Yeah. Yeah, I'd love to hear more about AIIQ and how you guys are working together.
What's up? Hey, so let me share. Yeah, let's
You teleported.
Okay, so let me I'll show it here. Okay.
You want to pull it up then?
Yeah, give us a little bit of like the problem and solution, what's the background of why you worked on this and what's it solving?
Live podcast.
Yeah, hell yeah.
Right.
Yeah, so it came out of my like desire to figure out what models I should be using for what tasks. And this was like 2 main aspects for it. Like, one is certain models are better at certain things, and there's no like one clear model that's better on everything. And then the second is like cost effectiveness. So there's sometimes where like you want to be able to complete a given task for a lower price, or you
show the chart here.
Yeah, there we go. So this is AIQ, and here we go.
It's showing just this.
I was showing just this corner.
It's showing just that.
Oh, just this right here. Okay. Oh, just this window. Got
plus
it. Yeah. Here we go. So can we see this right here? This is a larger version.
You still see it, Dougie?
Do you see the full chart?
See it. The text is really small, but it's like full screen now. I don't know if you can make it.
Can you zoom in?
All right, let me just zoom in here. Like that. I'll just zoom this. There we go. So yeah, this is our like main chart. So I mean, the other thing that we saw was that there are I think that's there we go. Okay. There are certain benchmarking sites that will give you like some kind of score, but the scores are often meaningless to people.
Right.
Like if you're of like an index and it says it's like a model scores 45. Well, what does that mean? So what we try to do here is have some value or score that's actually meaningful to people, and we decided to do like IQ. So because that's like an interesting reference point for people, right? They can see all right, well, if, Fable 5 is scoring 131 IQ, that's kind of interesting. That tells you something, like gives you a general ballpark of like how smart the model is. And then you can compare it to people broadly, but then you can also compare models to one another, and you have like some reference point of what a given score means. And then we develop the IQ score based on this. It's like composite IQ based on these different IQ dimensions, like mathematical reasoning, scientific reasoning, abstract reasoning, so on. And each of these are different components that feed into the IQ score. And we have all these benchmarks here. There's a ton of individual benchmarks that you can go and see. But the idea here is like just to figure out like what are the best models for your use case, so that you can go in and know what models to use for what.
Mm-hmm. So like, practically, it's really interesting. So it's one thing if we're just chatting with these sort of prompts we don't use repeatedly, like then it's like, hopefully we learn in time like what we need. But like for something, for example, that's going to be run 100 times a day or like 1,000 times, like this part of some automation, that's the kind of place where we can really bring down costs if we know the right one to use. I remember I built an app and there was like simple stuff, and I was like, okay, let me get the cheap simple models, and then there was some smarter stuff. I'm like, okay, use the smart. That was my best guess, but like I never really like knew where to go and be like, hey, here's my prompt, like which model do you recommend I use to get the fastest, cheapest, best needed for this level of complexity? Is there some sort of aspect, like some sort of UI like that, where I can ask AI IQ, like, hey, what should I use for this prompt?
Yeah, we don't have that yet, but that is something that we want to add.
Cool.
Launched that today.
Yeah.
Yeah.
Is there? Can you give us a good example of a type of task that you've had, and we can kind of?
Yeah, sure. Like you could think of like two things. It's like, hey, I've got this hour-long transcript. Can you summarize it into takeaways and action items? Versus, I've got this hour-long transcript. Can you pull out like a full-on, not just that, but also research some of the companies we've talked about, put them in a matrix of like, I don't know, competitor and analysis or gap analysis, like a little bit more of like a robust. So like same thing you're working from, but like a lot different output you want.
Yeah, totally. Yeah, I mean, like there's going to be certain models are better at research, like deep research. Certain models are going to be better at extracting the, to being grounded in documents that you're looking at. So for example, if you have a use case where you want to see, analyze this, 200-page PDF, and I'm going to ask you questions about the document, but I want you to be grounded in the document. Don't go off of what you already know. Don't go off of what you find on the internet. Because there's some domains in which like you might have a document with research that is cutting edge, that is beyond what is publicly available, and you don't want the model to contradict the document. It turns out that there are generally models that are really good at this type of task will be worse at certain types of knowledge or research tasks, and vice versa. So as an example, the grounding facts in a PDF, surprisingly, Gemma 4 does the best on that. So a 26 billion parameter model that you can run on your own local machine does better than GPT 5.5 and better than Opus 4.8, which is crazy. Yes. Yeah. Wow. That's one that like there are individual tasks like that where a locally run model can perform better, right? And that's just shocking.
Incredible.
Can you find it?
We don't have that benchmark right here on this, but that's something we're adding. So that will be up by the end of the day.
Show another one?
Yeah, we can show another one. Let's see what else is interesting. Design Arena front end is pretty interesting. Or let's see. Designer. Yeah, this is pretty interesting. So Arena AI Web Dev is pretty interesting. Fable 5 clearly performs the best, but GLM 5.2 performs second best.
Wow.
So what
It's
are we looking at the
outperforming-
horizontal axis here?
So this is the arena.ai is a great, another great benchmarking site. They specifically focus on user ratings and rankings of models that as they're using them. So it's kind of like user subjective user reporting of which responses they prefer. And they have a web development category. And this specifically looks at web development tasks. And so this score is like this ELO score is a report of what users prefer relative to other models on the web development tasks. And so when you see a model with a high score, that means that model is preferred to other models on this type of task by real world users and real use cases. Less than it's different than a traditional kind of objective task-based benchmark. So what's happening here in this chart is it's showing that Fable 5, clearly the best for web development, but GPT 5.2 is pretty close behind. It's very interesting. And not only that, it performs better than Opus 4.8 and better than Opus 4.7 and 4.6, and much better than GPT 5.5, which, this is kind of web development UI is a weakness of GPT 5.5, whereas the Anthropic models are known for being very, very good, the best models at web development, UI, and UX. But it's fascinating that you can have an open source model, GLM 5.2, which does better than every available model that Anthropic has right now.
Yeah, that's what's incredible about this. But the average person would never know about,
Yes.
and I think that like bring in first of all, this is like a beautiful website, and it's really cool to see it. And I imagine just the way you're getting all this data is very efficient and up to date. It's like incredibly cool.
Yeah.
I guess.
Oh wait, real quick. Look at this. Also look at this. This is another interesting. This is a companion chart that shows that same benchmark against the effective cost of the model. And as you can see, you can get near Fable 5 results for if cost is more important. You have this kind of like this curve right here. These are called what's called isoquant curves, which basically is a reflection of how you weight different trade-offs. So the score on web development versus the cost. And so if cost is super important to you and you kind of weight costs more, well, now this
even slightly more
important, right? GLM 5.2 is clearly the best model for you to use because you're going to get near Fable 5 results on web development for, $5 instead of $100 for a large project, right?
I gotta ask, because Joseph had sent a chart out, and I forgot to ask this question, but maybe it's a standard that I don't know. Why is the x-axis counterintuitive as what I would imagine, the small on the left?
Oh,
and
that's because at least I'm kind of trained in up and to the right is the best quadrant. So, kind of upper right quadrant is the best quadrant. And so cheaper is better. So that's why you kind of do an inverted x-axis.
Yeah.
And
is that
so
why you Joseph, that's why
you either have to explain to people like, oh, it's reversed from what you think, like actually left is better, and like no, people don't read that, don't understand that.
Yes, it's better to just like I mean we should make a clarification, but like upper right always better is like like one general way to think in the AIIQ site is the upper right corner is always the best, and the closer you are to that corner.
Both of you guys did that. Is that like a standard? Because like I think that's really interesting that you usually think of things getting bigger to the right. But in this case, bigger is worse, and that's why you've reversed, which is interesting.
It's like more desirable is further to the right. But actually, given that, let's go into one more chart right here.
I just want to show that I love this because you can say, well, cost doesn't matter to me at all, right? Money's no object, right? I'm Scrooge McDuck. You just move it all the way here, and now, the best is Fable, because money doesn't matter. This is the best. But if it matters like a little bit, suddenly GLM's the best. And if money's the only thing that matters to you, you just go all the way here, and you're like, okay, well, I guess the best.
I guess Mr. Large 3.
Wow, that's really fascinating.
Even though it's clearly really bad at it, it's like so most people are somewhere in the middle.
That's right.
And then you can decide if your application is more cost or more of this.
That's right.
And then he has other ones that are like 3-dimensional, but
yes, that's right. This is going to show next. Go to we go to the trade-offs site, trade-offs page. We can go down here. This is a pretty interesting chart. It's this is a 3-dimensional chart. Okay, now this is showing 3 axes.
Whoa.
There's a little bit of a mind fuck.
You could turn it.
Okay, so if you look, purple is best and red, a red surface is worst.
You need
Okay,
like a holographic version of this.
I know. Yeah, maybe you should
Like-
rotate or
like-
something.
like in space.
Wow.
Yeah. So if you the red, these are isoquant surfaces, okay, in 3-dimensional space. So the closer you are to the purple plane up here, the better the value of your model, right? Okay. And this is showing that the closer you are to the purple surface, the better your scoring, right? The better higher your IQ, the shorter your the lower your response time and the lower your cost. So we want low cost, we want high speed or low response time, and high IQ. And so the models that are highest up here have the best value across those 3 dimensions. And then what you can do is here's another kind of trade-off. This is a trade-off triangle, and this is showing that we're valuing IQ the most, and then money and speed a little bit. But if you let me actually increase this a little bit. And, oh wait, is that coming off? Yeah, that's coming.
Yeah, Joseph, there's actually this thing below. Oh, I think I can just take that off by going like this, right?
There we go. I think does that fit?
How do I take the bottom bar off that has my comment on it?
I click on the comment here. Hide. Okay.
Oh,
There we go. Okay, it's fitting. Great. Okay, so if you move this point, the surfaces are going to rotate. So the positions of the I know it's a little wild, but I'll explain. So this means, like, if I pull it down, it means I value money more and I value speed more. Okay, and if we rotate, we can see where the surfaces are.
That's so cool.
Now this is showing us a new ranking. We've just created a custom ranking in 3-dimensional space based on our preferences. Let's put it in the middle, right?
Why did you, for the 3D one, why did you rotate the planes as opposed to the points?
Because the values of the points are fixed. Whereas
The relations are fixed, but
yes,
you could rotate the same way we wanted to do up and to the right.
That's because then your axes would rotate, and that would be weird. It's a cube, so I guess you could rotate the cube.
Because you want everything to the right, top right. So maybe for 3D, maybe you want everything on the top. You know?
Yeah, I guess we could do that, but then you'd have like the axis. You'd have the X, Y, and Z axis literally rotate.
Yes.
You could do that, I guess.
What you're doing with this anyway.
Well, I'm rotating the planes in this case. Yeah, you're either rotating the planes or rotating the axes. We could try that. I'd be curious.
I like your idea about rotating it slowly.
Yeah,
and that's very futuristic.
Yeah. Oh, you can also change the pitch and stuff with this thing right here.
So I got like I got a practical.
No, well, it changes it like that. Yeah.
But that moves the points.
Well, no, but the plane is still.
Wait, this is just my view. This is my camera.
Yeah, that's right.
Like this doesn't move the points.
That's right.
This
moves the
my
points.
camera.
That moves your camera. Yeah.
Yeah.
So I got a practical question, guys.
If you value them equally, Mimo 2.5 Pro comes out best, which is super interesting. Yeah.
What?
Yeah. And then Grok 4.3 comes out second.
That explains on the Socrates, the base model is Mimo V2.5
yeah.
Ultra Speed.
That's
puts
right.
it even farther.
Even farther. So Mimo 2.5 Pro is the best for the intelligence, cost, and price at the same time. If you're valuing all 3 very highly. Now let's say you don't care about speed, you only care about IQ and cost equally. Well, this actually creates a GLM 5.2 is the best.
This doesn't make sense. Gemini is not. I don't know. I guess
Gemini is a very it's very fast for how smart it is. I'm sorry, it's very cheap for how smart it is.
It's very cheap for how
smart it is. Yeah.
Cheap. No, it says cheap. But okay.
And then if you put, this is probably a more realistic point for me, like money and speed I care a little bit about that, but I still care about IQ the most. And then we're gonna, interesting. Opus 4.8 is number 1.
Is that it is fast, it is cheap for how smart it is, but it's still so much dumber than the other big labs that you're just like, why spend that much money? Like I'd rather use because it's closed. I guess GLM is maybe not as I don't know. Wow,
so I got a question.
Really outperforming.
Practically wise, guys. This is, first of all, beautiful and incredible data. Like, this is like data porn, I think you could call this, right?
Yes.
And so that's amazing. And there's plenty of data, folks that would want to review this and explore it and like geek out on it and probably glean insights from it, like, of what to use their tools. Now, a lot of people, it would be an overload for, they just need the facts, they just need the result, right? And so I'm bringing it back to the agentic topic, which is like part of like what we love to talk about here. I see at the top you got API. You can access your research through API. So as we move to this future where we're interacting increasingly less, perhaps with some sort of visual UI, we're increasingly interacting possibly either with text or even voice with our agents who are going off and doing our bidding, that we just want to find what it needs to find to do the best job it needs to do. Is the potential that, and it sounds like the potential also to both connect agents with Trusted Router, with AI IQ.
That's right.
Like, hey,
yes,
Router,
exactly.
I got this project I'm working on, and it can go through a company like Trusted Router or anyone else who wants to partner with AI IQ, connect with either API or MCP or whatever, get the decision that it needs, like get the plan with models from you, and then without ever knowing what happened, I got the exact perfect model for my needs. If I don't even want to know, or if I'm more technical, I could get like the granularity. Is that part of how you see this working? Is like, tell me a little bit about ways to use this other than just visually and like exploring in this way that you've thought about.
Yeah, that's right. I mean, that's exactly what Joe was mentioning with the Task IQ thing that we were thinking of collaborating on, where we would be able to kind of spin up a combo model, advisor model on the fly based on the type of task that you're presenting the model. And so it could kind of call the AI IQ API, pull down the latest information, decide what is the main model that should be working, what the advisor model should be, that the model should be able to consult, or kind of set like what's a panel that it should construct as an advisor panel, and so on and so forth, or use any of the different kind of primitives that Joe was talking about. So we kind of envision some interesting collaboration between Trusted Router and AI IQ to produce the best possible serving of models to the user.
Right.
Thanks for giving us that idea.
I know we've been talking about that.
Totally. I'm a product guy. I'm always thinking of like how to like turn these technologies into products. But yeah, so I can also see like this amazing potential of like I'm dealing with OpenClaw right now, and it kind of goes into this box. I have no idea what it's doing, and so this is it's something really valuable, especially as things like cost. We talk about this, Joseph and I, every week. It seems like as subsidization of these tokens begins to be not as realistic, this importance to businesses, to everybody, of running their OpenClaws or their internal company processes, cost is becoming increasingly important, in the age of real token prices, right?
Yeah, I think it's also helpful because if the top labs see that there are people have these options available to them that are low cost and high performance, then they're probably less likely to end their subsidization.
Interesting.
Yeah.
I mean, because that's a calculation for them, and I don't.
You think less likely?
I think they're less. I think if they knew that they didn't have to, if there was one lab that clearly pulled ahead, it would probably end its subsidization.
That's right. And but also the fact that Fable didn't even end it, threatened to end it in 2 weeks.
That's right.
The subsidization.
That's right.
Everyone freaked out. Looking at open models.
That's right. So I think even if you have competition that is not quite as good, it provides a check on runaway pricing.
Although now, again, with Trusted Router, we do have things that are even better. So why even pay?
That's another dimension. I mean, you can get near performance for much better cost, or you can get better performance with a combo model. So those are both good.
Still lower cost.
Yeah.
So check this question out, especially like maybe, so there's the people that like are interacting with it maybe on the much simpler level. They just want fast, cheap, private, all those sorts of cool things. And then their agent can do their thing for them, or they can get like recommendation of what to use for their business process. However, in this era where people are getting their own physical boxes as well, because people want to save. I mean, I'm spending $50 on. Well, I was spending $50 a month on Vulture until I bought one of Joseph's quill feathers, which I think it's coming in the mail like any day now. I'm incredibly excited.
Yeah, I gotta mail that. So.
Yeah, send me the tracking so it's not sitting in my mailbox down the street.
Yes,
whenever it happens. But that's going to save me money every month. And so everyone's going to want their home agents. They're going to want their open agent. Like, we really believe of owning your agent. In fact, we're going to probably rename the live stream Own Your Agent, because it's a real tenet of something we believe in. While there might be conveniences for things like Claude to be our Omni agent or Gemini, I like, and I think Joseph and probably we all agree here, it's like, let's own our master agent and have them call on whoever's needing whenever we need whoever else. But I want to be in control of mine. But it can cost a lot to run, and so not just the hardware, but people are getting these Mac Minis, or I'm getting my Quill Feather, or these other cool little devices people are seeing, and there's this market for those like at-home boxes now, because people want to pay this VPS, or these in the cloud machines. But that also opens up the opportunity to have, like what you're talking about, open source or local models, right? Especially ones that are fast on this hardware that isn't super expensive hardware. So then there's this combination of like, okay, what could I have locally? And I don't even know if Trusted Router is set up for something like this, that it could know. It's like, hey, you've got that model local. You don't have that model. That's an expensive cloud model that runs on fancy hardware, but it can use a mix maybe of like some local stuff here for this part, some cloud stuff here, and string together local and cloud.
I was thinking about building that, although the more I learn, like a lot of harnesses already build that in, like Hermes has a multi-router thing, so I presume it's already doing that. I'm not sure. Would that be useful to have a router that like decides whether to put it locally or to another router or a different router?
Yeah, I'm not sure. I think there are. Does VLM have that?
People don't run VLM locally. VLM is like production grade stuff.
Meaning, like, if you had no models locally, it's just everything happens in the cloud. Versus if you're like,
right.
that
would be interesting
locally,
sure,
and then it's like,
Sorry, if you don't have it locally, what do you mean?
Yeah, if you have your box in your house, but you have no local models, everything just runs in the cloud. You pay per tokens, or if there's any free ones out there, I don't know. But say you then have Gemma locally. Could it
You have a model.
Hermes does support this. I think
so. It's kind of like knows when to pull.
Yeah. So you're using Hermes yet?
Not yet, because I don't have my new Quill Feather.
Oh, you only okay. So you only set up OpenClaw on both.
I set up on OpenClaw.
I'm pretty sure that OpenClaw supports this too. I think you can hook up with OpenClaw you can have multiple providers. You can use OpenRouter, you can use Trusted Router, you can have direct connections to OpenAI and Anthropic, and your OpenClaw will be able to use all of them, and it can like make a decision there. You can decide to route it locally, or it could go through Trusted Router and then use models in the cloud.
That's why I would make Quill Code probably do that same thing that OpenClaw and Hermes are doing.
Yeah,
I'd probably have Quill Code do local first, and then Trusted Router if you have local. But in practice, I think if you're actually sitting there, you probably prefer to do things in the cloud because you want to use 100 agents in parallel. In my experience.
Well, you want to use 100 agents in parallel. I think for the average person, they're like doing their OpenClaw with one little thing at a time. I mean, I don't know, but yeah, it's a good point. Depending on you.
Maybe today, but give it a few months. Like everyone's going to be just spinning up. It's like saying you only want to search like this book instead of using Google. Like, of course you want to use Google and search the whole web in parallel. Why wouldn't you? Yeah.
Well, guys, I wanted to ask something, but go ahead if you were going to finish. But I wanted to ask,
you wouldn't. The reason you're only doing one at a time now is because we haven't figured out the ease of use convenience for someone to spin up 1,000 in parallel.
And also they're going to get 10x, 100x cheaper per agent. So
that's true.
The cost of each agent is going to keep going down. The tooling to spin up many agents is going to keep going up.
With RAM as the main limiter, actually. We'd already have 10,000 agents in parallel if we had more RAM. So you want to be able. Okay, Fable. Did you use Fable?
I used it for 1 week, or I guess for 4 days. I just happened to have 2 amazing projects for it that I
Nice.
used it for those 4 days, and it planned out the entire thing, and the plans were so good that as soon as it
So
went
good.
offline, I was able to use
Yeah.
Opus to actually
So Fable at one point when you typed make whatever in one sentence, it launched 100 agents in parallel. I don't know if you noticed, but it had a little grid and it just did everything in parallel.
Yeah, for sure.
Like that.
crazy.
Yeah.
So that seems to be a big part of what's making these like frontier models perform better.
Yeah. And so if you wanted, you can do stuff locally, but it's not going to be anywhere near frontier, because what's going to be frontier is if you run 100 talking to each other in parallel in the cloud.
And that's improving both the speed at which it can deliver results and also the quality of the results when it spins up
Yes.
100 agents. Is it doing both of those?
It's doing both. It's the same, and it's the same reason why trusted router combo models are better, because when you use more models in parallel, you're faster, cheaper, and smarter.
And we have more
It's like
control
their
also
own-
when we do harness engineering as well.
You can tune it, as
Yeah.
opposed to like right now Fable is doing your work for you, but you don't even know what's happening. Like you're just
Right,
like,
and it's all-
okay,
it's
I
all
hope it's
anthropic
working,
models.
and maybe
Correct.
it is smart, but by providing all the tools using open source models, you actually know what's happening.
Yeah.
And you can go in and say, well, actually for my problem, actually I think this advisor would be better. Or like, or I trained a small LLM, let me use this instead.
Or you're having your LLM just decide for you based on the task.
Actually, that could be interesting. So instead of just OpenClaw using a local and that, or the cloud,
Yeah.
I could build into Trusted Router a callback where you could be running your own combo model, and then for one part of it, it calls back to your SLM on your local machine.
Yeah.
That's what I was thinking. Like that sounds really cool.
Like cloud to desktop.
Yep.
Yeah.
That's interesting.
That could be
Because
interesting.
then you are still harnessing. Then it's still like it's leveraging Trusted Router, but Trusted Router just knows where to get the information from.
Yeah.
All right. So I wanted to talk briefly about something that came up this week that I think a lot of people are unclear on. Because everyone's like learning in different stages, and I'm part of some groups that beginning to get around this concept of what I think you guys are much more familiar with, and people who are doing things like using 100 agents, this idea or concept of loops. Okay. And so the more people are talking about loops, more people are talking about, outcome. So it went from like this prompt engineering, and it's like, here's what I copy my human workflow. And it's like, whatever, but your human workflow might not even be great. In fact, you're teaching AI sometimes a subpar thing. And this idea of like outcome prompting, where you really like, hey, I want this thing, find the best way to solve it, or like whatever. This concept is of loops. Can you explain it? How have you leveraged it in your work? Is this part of the thing that you're using to run agents for days? Like, for those that don't understand the concept of loops, because it's relatively new, maybe you can clarify.
There you go.
I've been using a loop to make Quill Code, which is our Codex clone. I went to Codex and I said, make a clone of Codex, and I set a goal, and it's looping now. That's going well. So I put in 2 copies of that going in Codex. So it's using up
So in
my
Claude Code, you use like a / goal.
in Codex. But
in
then I think Claude has those now as well. So I went to Claude, and then I brought in Claude because I have 5 subscriptions. So I have Claude going, looping, improving through PRs. The Quill Code is all open source, and I also have Codex going, and it's good. Claude is more better at design. The Codex design is not very good.
Yeah.
And so these loops, whether they're called loops or goals, is like you're giving it an end result, and you're probably giving it a bunch of like training of like things it needs. Because it's like that running for days, and it's not even asking you for things. Like you need to give it a bunch up front, so it has everything it needs to go churn for
That's right. Yeah.
hours of days, right?
Yeah.
So
and
part
I
of
would
it's
say,
knowing like what it's going to need in order to do that. Like, do you have pre-prompting where you're like, hey, I want to set you this crazy goal, but I don't even know how to give you the loop or the goal yet. Can you help me come up with the plan to then
You can
give
totally
you
do
the
that.
handoff?
Yeah.
That would work.
Describe
Yeah.
that a little bit.
I think the best one I've heard is you'd tell it, grill me, like interview me about this whole project and ask me. And then if there's anything that you don't know, because it's smarter than you and like it's asking you about things you don't know about, you just tell it, I don't know. You decide.
Yeah. And then you ask it like, create a readme.md, right, for the general project, create me a plan.md for executing on the goal,
Yep.
agents.md for context for the agents, and it'll create those three and then ask it to give you a goal command. And then in Codex, you just type in /goal and paste in that command that it gives you.
I didn't do that. I didn't ask it to give me a goal in the command. That's a good
Yeah.
idea.
And so
Oh,
with that,
cool.
so you're kind of, you have it interview you, make sure that it has the right context. You prompt it to create those three documents and the goal command.
You should use voice mode for the interview.
Yeah.
You should have an interview with voice.
And then so you can get started with a super simple. It sounds daunting to try to put together like a loop to be able to run. But the best, if you're going to start with something to just as a demo, just have it say like, hey, I want to create this type of app. And here's a reference app, you know, for, you know, you don't want to, ideally probably don't want to tell it to exactly copy that app, but
I told it to use computer use to look at Codex to see how it works.
You tell it to use computer use.
But I did it. I told it also to do deep research on Codex.
Yeah.
Like go over the whole and figure out how all the features in Codex, make a list, and then make a table in the repo that says what the feature is, why it's building it, a test. It's like a workflow test, and whether it's completed.
Probably also give it a caveat. It's like, hey, just make sure it's kind of legally distinct, and so you're not like,
right.
You know. But aside from that, it's able to actually like check functionality, look at other apps in in this space, and then you can have it create like a Google Sheets type application or whatever you want that's yours and is local and is private. And so you can have it like kind of make any app that you want, and it'll run in the loop and it'll make it, and then you have it.
Incredible.
But the clearer your instructions, which you can help Codex or Claude Code help you get those instructions, and the more that it's able to check through the browser, like both the reference app that you're referring to and the app that you're building. It needs to be grounded in the goal, like the actual like, and it needs to be grounded in its current progress and be able to see in the browser, see the state of what it's built.
Very cool.
Yeah.
So you're giving obviously like, so it's browser control, or if you're using, you know, OpenClaw using like Playwright or something like that. So it can see, you give it a login for both the tool that you're referencing, and it can explore that, as well as the, you know, the login or like a full control over your development environment. So it can pull up its little local experiments and click through and explore what it's created and kind of cross-reference and run its own tests and keep checking itself and just run with it. Is that kind of what we're looking at?
Right. Yeah.
Neat. And so you're basically then, it sounds like that more work you can do up front to give it everything you need. And it's funny, Joseph was saying interviews by voice. Personally, what I do is I started realizing when it suddenly created an essay of questions, like I have all the things I need to get started except these 20 questions. And it's like this big list of wall of text. And I'm like, this is a pain. I used to, back in the day, meaning like a month ago, I would be like, oh, 1, answer to 1, 2, answer to 2. And now I just say, hey, give me a, make my feedback for you into a nice HTML page with inboxes and bullet points and radios and more description input.
Oh, nice.
And
That's cool. Yeah.
It gives me a UI that I can, and it's a one-time UI to give
That's
it
super cool.
really good feedback.
Makes it easier to fill out, more enjoyable. Right?
Yeah. And that's in the Claude app. And usually what it does is it has like a button at the bottom that says like either submit or it's like copy markdown. So you fill it all out and then you copy it as markdown and then you paste that back in, and it's like formatted for it's like as if you were doing it responses.
You get 20 questions of clarification. I get like 2 or 3, maybe 1.
I guess it first of all depends on the quality of what you're putting in.
Yeah.
And if your clarity of what you're putting in, so I'm building right now an agentic platform for businesses that like everyone can have their own Slack-based agent that goes in and its company, you know, accesses the company brain and gets some access to different tools and whatnot. So it's very much like I'm developing this thing from scratch, looking at different products and being like that's the thing I was thinking about when we started talking about loops. Is like I built the structure. It's now like ready to play in. And I'm almost want to set it like this loop of being like, hey, here's some cool tools and functionality. Here's this is kind of what I wanted. And I wanted to sort of set it on, leave it for a little while and see what it produces, you know? So I'm just getting my head around like how I'm going to do that next. But ultimately, because you're going from something clear, you're mimicking something that exists. I could see why that has less questions versus building something from scratch or that doesn't exist yet, or you have less reference for, probably does need more answers. I mean, that's why.
Yeah, I try. Yeah, that's true. And I think it learns what you like.
That's true too.
So it will realize, oh, this guy doesn't like answering all these questions.
Yeah,
I'll just decide for him.
So, all right, guys, in our last 5 minutes, like we've got covered a lot here. What are you excited about experimenting on? I mean, that you're actually going to be able to maybe get to this next week. Like, what's top of mind? You've obviously got some cool collaborative things, but is there anything you're really psyched about geeking out on?
We're running an experiment today.
Yeah,
it'll be pretty exciting.
Yeah,
we're putting together a bunch of open source models to so Mythos, the way it's proved that it's so good is it ran on this benchmark called Exploit Bench, which is entirely open, and Mythos is by far the best by like 3x. But I think
to find like issues in your code.
It takes a real program that's like hundreds of gigabytes, figures out a way to completely hack it entirely.
Yeah, like basically find a way in.
Stream together exploits, and
it's very complicated.
Yeah,
and it takes 8 hours per task.
Wow.
And so even the AI takes 8 hours. So this is like incredibly complicated stuff.
It can take like $1,000 per task.
Wow,
many thousands. So we think though with the combo models we can actually crack it as well as Mythos, which would give us a super class device.
Yeah,
using purely open source.
This is a great question. So I maybe begin wrapping up on
today if the results are good.
Yeah, we're running it as we speak. Yeah.
Mythos came out or at least started being released. They're like, we can't release this yet. We're only releasing it to governments and like top trusted, software folks and whatever. And that's great. And that was responsible. And then it came out and then maybe some stuff happened and then they kind of pull it back, or maybe it was just fearful that it could happen. But the reality is that it's going to come out again. And the further reality is that it's only a couple of months until that level of technology, or sooner, with Trusted Router or these other folks using Fusion, the method, that it's going to be out, right? Do you think the only answer to actual security is democratizing access versus like controlling access? Because ultimately, if you control access, the average person just can't do their biology research or like code enrichment, versus the bad actors, they know how to pretty much get it, and you're actually worse off having more access to more people.
Well, I tried to when I had Fable, I said, hey Fable, like look at Trusted Router code, figure out it's open source. I need to fix the bugs, fix the security, find a way that people can hack in. And then it said, sorry, I can't help you.
Yeah.
How is that helpful?
Yeah,
it's not.
So the Mythos level would have been able to do it, but the Fable model that we got was limited because they don't want people hacking other things. And in doing that,
but I can't even secure my own things.
Yeah. I think it's a problem. And look, I think it's a genuinely challenging thing. I get what they're trying to do. I get why they're controlling it. They're worried if they make it generally available, then everyone's going to start hacking everything. But it's a tough question, but I don't think that's the right answer. I think we need to figure out a way to have models that are very capable of fixing all of our software widely available. And so it's challenging. We have to figure out how to prevent widespread hacking, but
I want to harden.
We want to harden stuff. We have to figure out a way to do that. So
I mean, that's the thing. There's going to be some bumps, like with everything, whether it's jobs or like energy usage or like environmental things, like or hacking. There's going to be bumps. There's going to probably be some big bumps that are going to be like eye-opening things. But just like there were with any technology, this technology is moving so fast. That's what makes a lot of people concerned. Is like, it's not like things that just like, well, a little bit slow and then work that out. And the next thing was a problem. Like a lot of things are happening really fast. So I get that. But the reality is that I think democratizing, that's what I mean by it's like democratizing access to this stuff so people can fix their own things, so more companies can plug their own holes, and to try to like get ahead.
How can you own your
Are you unmuted?
Yeah, how can you own your agents if you're not democratizing?
I know. Yeah.
You're not
Own your agents, baby.
I think there's another thing that could be helpful, which is
in 1 minute, just to
okay.
just be
Just going on GitHub and submitting a lot of patches and kind of using things like that.
yeah, they can go do that. Everyone can do
Yeah.
that.
But anyway, yeah.
Guys, this has been so cool.
Yeah.
Honestly, Ryan, thank you for coming and showing your stuff.
Yeah, for sure. Thank you for having me.
You guys cook up, and it's been another fascinating session. Maybe the last time this is Agents for Humans, and next time it's just gonna be own your agents, because I really think that's something we connect on. We do not want to be dictated what we need to do, and we want access to what we need, and at the best, cheapest, most intelligent, most private level possible. So kudos, you guys keep up the good work.
Totally. I think that's the theme of the rest of the year for the world. Own your agents.
Yeah.
I love that.
Cool. All right. Love that. All right. Ending stream.